the thing, and I can keep an eye on this. Oh, crap.
Hello.
Hi.
Right. Whoa. We're here.
Whoa. Look, double trouble.
Look who's back.
Look who's back in the
It's
house.
Jono.
Oh, I'm
Jono's
always
always
here. People are like, oh, can we get someone else to do these? It's also on my computer, so it's loud. Hey everybody, welcome. Thanks for joining this live stream. It's John and Richard from Seneca. Richard's back. We missed him.
I'm absolutely buzzing to be back.
We're super excited for this GCSE maths live stream. Thanks for everyone who tuned in yesterday. We had Spanish and geography. Geography was bomb. Like, you guys came hard with questions. You were like sending us loads of cool recommendations for stuff.
You should have seen Jono's face when he came into the office this morning. He was like, oh my god, geography was so good.
It was so good.
Loved it.
I really, really liked
Absolutely
it. So I hope it was useful, and I hope the exam went well today. Let us know how that went. And you, like, we got an upgrade. Look, these people are enjoying these so much. We got a new microphone. Look at that. So hopefully the audio quality is better.
Yeah, and we've also, obviously.
Oh, what's that for? What's that for?
You know what it's for, John.
I know what
you
it's
know
for.
what it's for.
I know what it's for.
Jono knows. Jono knows what it's for. Where's Jono going?
It's for the gong. I don't know. I'm just so used to being locked in that tiny room. It's a gong.
So if you haven't seen our live streams before, what we use the gong for is every time someone gets something right. We're still doing that?
Yeah, we're still doing that. We're still doing that. And also, because we're not in that tiny little room, we can gong really loud because no one weird is going to walk past. And if these keep being popular, we'll maybe be upgraded to this room permanently, which would be awesome.
We're relying on you for that, though.
Please. We need to. So, okay. So what we're going to do today, you guys have been giving us requests for content all day. So we're going to go over the key topics that have come up. I think there's some functions involved. Bearings was a big one. And so we're going to dive in and do that.
One of them was probability.
And probability.
We're going to look at some probability as well.
What's the probability of us going over some probability?
I'd say 1.
Oh, that means it's definitely going to happen.
It does.
Let's dive in.
He's on it, isn't he?
On it.
You're not getting a gong for that, though.
What? Why not? I thought that was a good one. I've also got some chalks. Don't know who this is from the office, but
we've been using it, so thanks.
Thanks whoever left.
Let's hope no one in the office is watching.
Oh yeah, that's a good point.
Right, so should we get going?
Let's
should we
get
have
going.
a look at some stuff for your paper 2 tomorrow? First of all, like, same normal stuff applies with maths in terms of make sure you read the question. It makes sense to underline stuff that is relevant in the question that you might need to know about. Also, like the action. But also just, like, I think, check through your work at the end as well.
Yeah, definitely.
It's really easy with calculator papers to type stuff into calculator wrong.
Yeah, always good to double check.
Like, you think, oh, I'll just type into calculator, I've got a calculator, can't possibly get things wrong, but you'd be surprised how many people write the wrong or press the wrong buttons on the calculator. Yeah. Always double check. And also always keep writing out your working, even though you're typing on a calculator, write out your working, because so many students can just make a silly mistake when you're typing something in. So show all your working, and it will. And that shows the examiner what you have done, which can get you marks. Exactly. And thanks for all the requests that are coming in. Keep them coming in. If we have some time at the end, we'll do some extra stuff. And for anyone who's watching this after the live stream, speed us up to ×1.5 or ×2 speed for your own benefit. Yeah, then you can get on with chilling out or doing a little bit more revision, whatever you fancy. Okay, so Rich is going to share his screen with you guys. And I am indeed. We're going to get on with some, what are we going to start with, Rich? I think we're going to start with bearings. Oh, yes, yeah. And that's good, because bearings are hard. You'll have to bear with us, though. Oh my God, was that a maths joke? I think that was a maths joke. I'm loving this. Ooh, okay, so there's going to be, our faces have momentarily disappeared, and we're doing this for your benefit, because you shouldn't stare at us for too long, you'll turn to stone. So while we get the cameras ready, we'll talk about what we're going to go over. We're starting with some probability questions, and it's going to be awesome. John, can you look up the login? I would love to do that. Why don't you start talking through some questions, and I'll get the login, and our faces will reappear momentarily. Right, so let's get going with some probability. So we're going to have a look at a question that you might see tomorrow, and this is like from one of our predicted papers. Yeah, it is. So
Well, let's start by going through the questions. So Kanye has a bowl of 11 grapes in his recording studio because grapes, they're really good for your skin. 8 of the grapes are green grapes and 3 of the grapes are red grapes. So good. It's making me want some grapes. And he randomly picks 2 grapes from the bowl. So this is how all the probability questions are set up. So this will be useful to apply to all of the questions that come up. So, the countdown is
countdown is on.
So you will see us very soon. So Richard, what are we going to do to answer this question?
So basically, what you've got to start with by thinking about drawing a little probability, what we call a probability tree.
Yes.
Right? So the question says, which of the following tree diagrams correctly displays the probability that Kanye picks the first and second grape from the bowl? Okay.
I love a diagram.
So basically, what you've got to do is you've got to basically be able to draw one of these yourself.
Yep.
So the way you do it is you think, okay, there are 2 options. Either he can pick a red or a green grape. Okay, so you basically put a little thing that looks a bit like that, little wedge.
Yeah, like a
wedge,
like a sand wedge.
Sand wedge.
Great for no, what you wear on the beach in summer. No,
that's what you were making a bad sandwich pun.
No, I was thinking like wedges.
So you do this, and then you put like red here, or let's put green here because that's the top of the question. Green here, red here. And then you can put the probabilities on each of the lines. Yeah. And then from each of those ones, you can put another wedge, another sand wedge, Jono's favourite, to show the probability again. Right.
So which one's right? Which one should we pick? We've got an option of 3. So guys, shout out! There's a gong coming up for whoever can pick the right probability tree diagram. Let's go. Say what? Oh, number 2. Let's go. Do you mean 2 on the top right? I think we're getting top right. Should we?
Top right.
Let's go top right. Boom!
Oh,
that felt good.
That hurts, mate.
Sorry. I'm sorry. He just got back. He's like,
especially with the extra. Like good microphone.
Sorry for anyone who's in headphones. Let's carry on with some more probability.
One thing to say about the probability. One more thing to say. Okay. Something that I think probably missing from this question actually is to say that to say whether the grapes are put back in the bowl or not.
Bowl,
okay.
Yeah.
So in this case, it's been taken. So he's taken 1 grape.
Yeah.
Okay. So what you've got to do is think about, okay, if he's taken a red grape, it started with 3 out of 11 of those grapes being red. But then if you take another red grape, you've only got 10 in total left. So you've taken 1 out, and also you've lost a red one, so you've only got 2 out of 10. And you apply that same logic to any of the little ways you go through this.
Awesome.
Okay.
Cool.
Right. So if Kanye picks 2 grapes from the bowl at random, what's the probability that Kanye takes 1 red and 1 green grape?
So this is always, so I always, with this question, you want to look out for that key question word. Is it an and probability question or is it an or probability question? Because that's going to determine what you do next. What's the difference between an and probability question? Let us know. But Rich, should we go through this question?
Yeah, so two grapes in the bowl at random. So you can use your probability tree that you've drawn, hopefully in the first part of your question, to basically answer the question, right? So it takes 2 grapes in the bowl at random. What's the probability to take 1 red and 1 green? So there's 2 different ways of doing this, John. Do you know that?
Two ways. Also, you guys are killing it in the comments. Amazing. Multiplying and or is
this might sound a bit weird.
Yeah.
But you can either take a red and then a green.
Yeah.
Or
stop doing this is a lot.
You can take a green and then a red.
Stop, that's a lot to take in.
And that's different. Right? That's 2 different ways of doing it.
That's a lot.
So you need to know basically, so probability to take a red grape and then a green grape is 3 out of 11 times by 8 out of 10. Oh, what am I doing there? 8 out of 10. Boom. Okay, and when you're multiplying fractions, remember you just multiply across the top. So 3 times 8 is 24, and 11 times 10 is 110. Boom. And then I remember I said the second way of doing it, green and then red.
Yeah.
So if we go up to our tree diagram here, we go green and then red, so it's 8 over 11. 3 over 10. What are you laughing?
No, I'm just like, everyone's just like, hey, hi guys, we see you. Everyone's shouting out hello, but also answer the probability question.
Answer the question. You got your maths exam tomorrow.
Yeah, exactly. But
so then the last thing you do,
hi, it's Mizzy.
Hi.
So you've got some questions.
You've got those 2.
Hey, tomorrow
those 2 different options. What you then need to do is basically add them together.
Plus and plus.
Okay. Because you can either do, so someone said and is at times.
Yep.
Or is a plus. So
Yeah.
you could either do the first route,
Ooh, yeah.
red and green,
Yeah.
or you can do the second route,
That's
green
a
and red.
good
So you
question.
add them together.
That's a good illustration of the and or principle for probability.
So then you simplify.
Guys, awesome. You're doing so well in the answers. Everyone's shouting out 48 out of 110.
Again.
And then simplify it to its like lowest common denominator.
So I've just divided the top and the bottom by 2.
And it's a calculator paper. So guess what? Just do it on your calculator.
So I'm holding up 4 fingers while saying divided by 2.
But like, it's okay. It's okay. No one's perfect.
Peace out.
No one's perfect.
8 times down.
Yeah, nice. Okay.
Right.
So so that's a bit of probability. I think and/or is the big thing to go over. Should we maybe switch to a different topic now?
Yeah,
What
100%.
do you think? What are we going to go for?
Bearings.
Bearings. This was someone got in here early. Someone was in this room at like noon and was like, "Can we go over bearings?" And I was like, "I respect how early you are for this live stream. We are going to do a bearings question."
So 3 things for bearing.
1, 2, 3.
No, other way around.
Okay, other way around. That's all good.
Yeah. So 3 things you need to know about bearing.
Yeah.
Number 1, you always measure from north.
North.
Number 2, you always measure clockwise.
Yeah.
I'm not sure if this is going to be mirrored for you or not, but for us, this is clockwise, but maybe it's that way for you. I don't know. So if you're not sure which way clockwise is, look at the clock in your exam, because there will definitely be one, and you'll be able to see which way the clocks are ticking.
Yes.
Number 3.
Stress.
Always 3 numbers.
Yeah.
Okay.
Yeah.
So if you've got a bearing that's 9 degrees, say, you always write it with 3 numbers. So you say 0, 0, 9.
Okay, that's good.
Or if it's like 12 degrees, you write 0, 1, 2 is the that's the bearing.
It's a bearing.
If it's like 110, you don't need to worry about it because it's already three figures.
Perfect.
Right?
Perfect.
So those are basically the 3 things you really need to be careful of in the exam.
In the exam.
So what is the bearing here of from B to A? So that's the other really difficult thing about bearings.
Yeah,
it's like from B to A. What does that mean? And sometimes it says from A to B.
Oh
like what does that even mean?
I don't know.
So from B to A.
Okay, people are already shouting in with that answer.
So where are you starting, Jono? From B to A.
You're going from, what is the bearing from B to A? You're going B and then you're going round to A.
Yeah, good. Yeah. Right. So you're starting at B and then you're going to A. So here we've got B here,
and then we're going,
and A is here. So remember, here we've measured from north.
Yeah.
We've measured around. We've used our protractor if we've done it in an exam. And we've been told it's 200 degrees.
Yeah.
It needs to be 3 figures though, John. So what do we do?
We have to add a little. We've got to make sure there's 3 figures.
Well, we've got to make sure exactly. And
there
are
3
in there.
figures.
There are 3 figures.
So
it's already 200.
200. It's fine.
Oh, what?
I think 200 was one we were given. I think we wanted A to B, and A to B. That's the 20.
Oh, sorry, I was reading the question wrong.
It happened.
This is why I need to. You just might need to read the question. Sorry.
Properly.
Okay. So what is the bearing of A to B? Apologies. Right. Shall I explain now why that works?
Do you know what? I would love nothing more for you to do that. And also, I see you guys shouting requests out in the chat. That's great. If we have time later, we'll try and do a history one. But I'm not sure if we'll have time today because there's lots to do at Seneca HQ. But we will do our best. Let's focus on these math and these bearings, though. Let's do this.
So from A to B, if you know that angle's 200, you can use that the angles around a point are 360 degrees to work out that this one is 160. Okay. And then you should know that these 2 angles together will add up to 180.
Boom.
So you know that this angle is
on the side.
This is 20 degrees. And actually, the bearing should be 0, 2, 0.
We're going to fix that. We're going to fix that.
Right, should we look at someone else?
Yeah, should we go over some functions? And
what's the live chat saying, John?
The live chat is, can you hear us okay? Someone's saying they can't hear us. And yes, can anyone, I think, if you can't hear us, keep sounding out. We are going to we've got loads of questions to do, loads of functions requests. So we're going to do some functions and we'll go with, like, it's going to be great. F of X, G of X, it's all good. And I'm seeing all of these requests. Don't you worry. We will do our best to do as much as we can. We are but one cute little startup.
Nice.
Okay.
So first thing to know about functions, Jono. I think this is going on a bit fast because it's from the hardest questions course.
Yes.
I think we first need to just know what a function is.
Tell me,
right?
what is a function?
So a function is basically something that takes something from one number, okay?
Yep.
Puts it through like a function, like almost like a machine, does something with it, and then it comes to, in front of John's face, another function.
Yeah.
Sorry, another number.
Okay.
So a number goes in, it goes through, it whirs around, and another number comes out.
Okay. Like, it's like instructions, right?
Yeah.
Yeah.
So it's like you've got one bit of wood, you put it to another bit of wood. It makes
Perfect.
2 bits of wood. Oh my god, it's unbelievable. Maths in real life.
This is a lot to take in for me right now.
So basically, say you've got a number that's x,
Mm-hmm.
right? And you've got a function we're going to call f. They're quite often called f or g or h or something like that in the exam. And what you say is f of x.
Uh-huh.
That just basically means you put x into the function, function f. Boom. It whirs round and it spits out another number. All right?
Like that. I didn't really spit. I was just doing sound effects.
So say you've got like a function that, so say here, this example, we've got the function f of x equals f squared minus 1.
Yeah.
Let's say that we wanted to put the number 3 through that function.
Okay,
right?
yeah.
So what we could say is that's f of 3.
Totally, okay.
So basically everywhere we see an x, we replace it with a 3.
Love that.
So here we've got x squared, so it'll just be 3 squared.
Then we'll do
and that's all we've got, minus 1. So 3 squared is 9, minus 1 is 8.
That was some quick math, Richard.
I know.
Boom.
So f of 3 is just 8.
Okay,
right?
amazing.
So 3 goes into the function, 8 comes out.
Yeah, okay, perfect.
Put 3 into g here. G of x equals x plus 3. Remember, g of 3, just put everywhere you see x, you just put 3, so 3 plus 3 equals 6.
Okay.
Nailed it, and some more quick maths.
Amazing, amazing. Quick math, amazing.
Right.
Stunning.
Second thing you need to know, John.
Okay, what is it? Give me some more information.
And this is what this is talking about, composite function.
Composite function. This is hard. This is like 7, 8, 9 territory.
Yeah. So composite functions, basically, what that is when you've got like, you do a function, you put a function through another function. Which is pretty mental. Right?
Yeah, that's
so instead of putting a number into a function, you put a whole function.
Oh my god, that's a lot.
It's not functional.
It's not functional.
We're
doing the fun and function.
The way we write it basically is you can see here we're basically putting g of x through f.
Okay.
Here, yeah.
That is a compound.
Which is a composite function.
That's what I
or
meant.
A compound.
You're
function.
welcome.
Okay. So the way we write that is we write f of g of x.
Yes.
And basically the one you do first is the bit that's closest to the x. So here we do g first, and then we put it through the x. So say we want to work out what f of g of 2 is. First of all, we put 2 into g of x.
Okay.
Yeah. So 2 into g of x is 2 plus 3, which is 5.
Yeah.
And then we put that answer into our f of x.
Okay.
Right. So 5 squared minus 1.
Like it.
So 5 squared is 25, minus 1 is 24. Okay. So f of g of 2, did I say 2?
Yeah.
F of g of 2 is 24.
Nice. Like it.
How are we sounding with that?
How are we sounding?
Should we try some questions?
Let's do some questions. Sorry if there's a bit of a lag. There was some drama trying to get the Wi-Fi sorted for this. I'm real sorry. But
right,
let's go.
So let's have a go. So say these answers as you go along. All right.
Yeah.
Okay. A few people still saying they can't hear. Are you sure?
Oh, let me like.
Just you can't hear at all.
At all, or is it just
like we're a bit fuzzy?
We're a bit fuzzy. We're a bit laggy. Let us know. Voice keeps getting cut off. Okay. Well, we're just gonna keep on going. And we're gonna
try and use a different microphone.
We're gonna use a different microphone and see if that helps.
So let us know if you can hear us now. It might be a bit more echoey, but at least you'll be able to hear us.
Okay. Yeah. Inverse functions do come up a little bit later in this.
We're going to talk about inverse functions about 3 minutes.
Okay.
So we're coming up.
Cool.
So let's look at some questions. So find the value of f of g of 2.
Yeah.
When f of x equals 3x minus 2.
Yeah.
And g of x equals 5x plus 1.
Yeah.
So talk us through it as you go. They reckon the answer is 31. Let's have a look.
Killing it.
So remember, f of g of x is the same as f of 5
boom
plus 1.
Boom.
And then substitute in the values for g of x. So we want to find g of x when it's 2. So
it's in it. Just do I just do like this. So then it's going to be 3 5x plus 1 minus 2, and then we've got to simplify that expression. So we just expand those brackets, and we get 15x plus 3 minus 2, and then again plus 3 and a minus 2. That's just a plus 1. Then what do? We substitute in the value x equals 2, because remember, it's a compound. Composite?
Yeah.
God damn, every time. So then we sub it in, and we know that it's going to be, we sub in 15 times 2 plus 1, and it's 31, which you guys were like so quick at shouting out in the chat. So impressed.
Nailing it. Megan's all over it.
Megan, boom, gone for you.
Poshington 01 also.
Love that. Awesome.
Yeah, Megan,
awesome.
my G as well, Dr. Tente.
Absolutely loving it. So I believe there was also some requests for an inverse function.
Well, as if we planned this, John.
I know. So
right.
prepared.
So inverse functions, basically, that is just basically going backwards.
Yeah, back
right.
like this. Whee! I can't go back too much. This room is really big. Richard, go.
Right. So we've just gone backwards. We've inversed on the function. So
yeah,
basically.
Yeah.
Say we put a number into our machine.
Boom.
It comes out as another number.
Yeah.
What is the number to go backwards? So if we know the number we end up with, how do we know the number?
It's like an ASOS return. You bought a nice little dress, and it's like, no, I don't want this. I'm inverse functioning this dress.
So it's called f of minus 1 of x.
Oh, that's a lot of ofs. It's a lot to take
so
in.
F and then a little minus 1 x.
Yeah.
Okay. So what we do basically is we just change f of x for y.
Yeah.
And then we rearrange that formula, or that equation, to make x the subject. That means, Jono, x equals.
X equals. X is the subject.
Come in.
Sorry.
Hiding over there. Right. So
trying to multitask.
X equals. So here we've got basically, like I said, change f of x for y. So y equals 2x minus 4 when f of x equals 2x minus 4.
Yeah.
And we just rearrange that by doing some subtraction. So we swap them around, so the x and the y.
Yeah.
We just change them over. So literally swap.
Easy, nice, done.
And then next we rearrange, to find what y is.
Boom.
So this is how you'd rearrange it. I'm not going to go through that. Like, that's just some algebra that, like, you know, have a practice of that in your own time. I reckon,
exactly.
You fancy
exactly.
It, right?
Exactly.
So the last thing to do is, once we've got what y equals, we just change it back for f of minus 1 of x.
Yeah.
So f of minus 1 of x is that. Nice.
Love an inverse function. Did that clear things up? I hope so. And I see all you sounding out in the chat. Hey, it's a lot. You guys are doing.
You're nailing it, guys. You're nailing it, and you're going to be great tomorrow. Should we go through a question, John, or do you think we should move on?
I think we should move. I think we should maybe move on. We've got the GIF is good, right? The GIF is good.
Great GIF. Great GIF.
I saw some requests for ratios. I saw some requests for vectors. I saw some requests.
Let's see if we can find a section on ratio.
Yeah. Let's go to. Oh, and 3 to 5 markers. That's a lot. Maybe why don't we go over direct and inverse proportion, because I saw that too. The GIFs are such a good part about Seneca, right?
I love a GIF.
I love a GIF.
Who doesn't love a GIF?
I don't know. I don't want to.
Do you think the Queen likes GIFs?
I would think she'd love a GIF.
I think she's
GIFs,
probably she's a big fan of GIF, isn't she?
Yeah, exactly.
Right. Anyway, direct proportion.
Direct.
So basically, what that means is, first we use this symbol. Yeah. It's called an alpha.
Hey.
Alpha Romeo.
Alpha Romeo. Beta theta.
Yeah.
Yeah.
So basically, what this means is x is directly proportional to y.
Love that.
All right. And what that basically means is we can say x equals something times y.
Yeah.
All right. So whatever x is and whatever y is, we can work out the difference between them if we know that what to times it by.
Yeah.
So,
exactly.
So this just means y is directly proportional to x squared.
So y equals kx squared.
Exactly.
Oh, so good.
So good. Right. So directly proportional, remember, it's alpha.
Alpha.
Let's not watch that video now. And then inverse proportion is another one.
Yeah.
Which basically means, again, it's you use this alpha, to show it's proportional. The inverse means it's proportional to 1 over that number.
Yeah.
So if you say y is inversely proportional to x, y is proportional to 1 over x.
1 over that. 1 over that bad boy.
1 over it.
And I saw some questions in the chat. So Paul was asking, like, if like what the best way to spend the night, if it's possible to do everything for a night. Just be confident in all the work you've done over the year so far. You would have picked up more than you even realize. Spend tonight just looking over some past papers you've done. That's really useful. And then from those past papers, go through the modules that you struggled with, just as a bit of consolidation, okay?
Yeah.
But you're gonna be totally fine. You're gonna rock it. It's gonna be over soon. Exams are just one like way to measure success. Life is successful in many different other ways. So they seem a lot, but there are many other ways to.
There's some really good websites where if you just Google maths exam questions by topic, all right, then you get a whole list. You can literally like look at all of the old probability questions all in one place, right? And so that's a really good thing. If you use one subject you're really struggling on, and often they have answers with them as well. So have a look out for those.
Exactly.
Right.
Okay.
Where next, Johnny?
So if we maybe like some, oh gosh, some like
bit stress buster.
Yeah, stress buster. Oh crap! It's been half an hour, guys. This has gone so fast.
Do a bit. Let's give the people what they want.
Let's give them what they want.
So I don't know if we've got any.
Should we circle? Let's do some circle requests. I don't know what a banker question is. Circle theorems. I'm seeing circle theorems. Should we do a little bit of that? Yeah.
Let's look at circles.
Let's do some circles.
Actually, no. I think circle theorems would be good. So
yeah, circle theorems would be good. We'll get it up. We're ready for you.
Circle theorems would be good.
Boom, 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 boom.
Right, I might not have time to go through all of the circle theorems.
We'll just do the quick ones for your exam tomorrow.
Right.
Okay.
So first one you need to know is that perpendicular bisector chord always goes through the center of a circle.
Yeah.
Right. So you've got, this is a chord A to B. That's just 2 points on a line on a circumference connected by a straight line. And if you draw a perpendicular bisector, you get through to the middle of the circle.
Yeah.
Easy peasy.
Boom, boom, boom.
Right. We're not going to look at the proof now. But let's have a look at another circle theorem, Johnny.
Let's do it. That's a good one, though. That was a good circle theorem to do.
Great start.
Oh, so this is my favorite one.
Is it?
Yeah, opposite angles.
I love that you've got a favorite circle theorem.
It's the best one because it's a shape within a shape. I'm like, damn, that is the kind of high octane excitement I want.
Quadrilateral, four-sided shape. Easy peasy.
Love it.
Opposite, if that's within a circle, so all the points are on the circumference.
Yeah.
You've got the opposite angles add up to 180.
180.
Boom.
Like jars.
180.
Okay, let's do the last circle theorem to finish because then that's half an hour up. Yes, they do have to touch the quadrilateral does have to touch the
the circumference.
Yeah, it has to touch the circumference. All four corners have to touch the circumference.
Otherwise, you could just have like basically quadrilateral just doesn't really matter. The circle may as well not be there.
Exactly.
The whole point is the circle touches it.
Yeah.
Okay.
So this is the last theorem, and if any other stuff you're stuck on, sorry if we didn't get to it, but all of the modules are on Seneca, so you can click through them, and they've got questions on there that will help consolidate your knowledge.
So last one.
Last one.
If we've got this like wedge shape here, so two radiuses,
love that,
connecting to the middle of the circle, and then this angle that we called theta here, but whatever it is, it doesn't really matter.
Yeah.
If you also go from the same 2 points to any point on the circumference, this angle will be half of what it is here.
It's a good rule.
Okay, it's a great rule.
It's not as good as the quadrilateral rule.
No. So even if I drew a line like this, Jono, like if I drew it over here, but then down to here, that angle that makes would still be half.
That would still be good.
Isn't that beautiful?
That's really great.
Isn't that stunning?
That's brown.
I think that's my favourite.
Okay, fine. We have our own favourites. We don't have to compete.
We're not meant to have favourites, John.
We're not. No, but favourite theorems.
Oh, okay. Sorry, favourite theorems.
Quick thing. Any tips you would give to go up from an 8 to a 9? Can you think of any?
So I think first of all, you need to make sure you don't make any silly mistakes.
Yeah,
last
that's a bit important.
Really, that's important for everyone, I'd say. But also spend some extra time on those last few questions because that's where you really make the difference between 8 and a 9. Okay.
Yeah.
So the last few tips, basically those questions will be like looking at combining different bits of knowledge you have. So it won't just be like one question on circle theorems.
Yeah.
It will maybe be like circle theorems mixed with probability and how you use that. All right. So like you need to know all those things individually to be able to work out and piece those things together. So I'd focus on, like, tonight, if you want to do a bit more revision, there's no pressure to. I'm not saying you have to or you should, but if you'd like to, you go away just focused on those individual topics and think about maybe how they pull together at the end. But just it's the last few questions that you're going to get that look at those 8 to 9. So focus on those.
Right, guys, thank you so much for joining. We're going to have to wrap it up there. I think we're having some Wi-Fi issues. I'm sorry, the lag is really bad. And because we got kicked out of the room we're normally in because the Wi-Fi in the office wasn't working. So really sorry about the lag and any sound problems today. And I don't think we'll be able to do a history one either, just because the Wi-Fi is not working really well. I'm really, really sorry. So I've been Jono.
I've been Rich.
And this has been so much fun. I hope this was a useful run through. Thank you for all the requests. We tried to do the most popular topics.
That was me thinking you'd like prepared like an end of session, like, I don't know, saying. I've been Jono, he's been Rich, and then you were going to say, and this is Seneca. Or something. I don't know.
Next time, let's do that. Let's finish it now.
Can we get some suggestions of how to end our podcast?
Yeah, that would be
podcast. What are these called? Live stream.
We also do some great podcasts though.
We do, yeah. We didn't mention those.
Yeah, I did an A-level bio one today. Like, check that out. Even if you don't do A-level bio, it's a riot. It's so much fun.
Right. Okay. He's been Jono.
I've been Jono, and I think we're being kicked out of this room. So
I've been Rich.
He's been Rich. This is Seneca. Thank you. Good night.
Thank you and good night.
Is it still going?